Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.68 from the book Thermodynamics and Engineering Approach by CENGEL, 5th edition. So the statement of the problem is a piston cylinder device initially contains steam at 3.5 megapascal. Initially, pressure is given to us as 3.5 megapascal. Superheated by 5 degrees centigrade. Superheated temperature is 5. Now it means that, let's suppose I explain this point from the TV diagram. Temperature in degree centigrade and specific volume in meter cube per kg. So this is saturation curve, and now at 3.5 megapascal, let's suppose this is constant pressure line. This is constant pressure line, and 5 degree superheating means that after saturation, after this point, this is heated by 5 degree. From this point to this point, this is point 1 because start is from this. So start point is 5 degree heating from saturation temperature. So this is point 1, and from this point saturated liquid line to the point 1, the temperature is 5 degree. So this is superheating temperature. Now steam loses heat to the surrounding and the piston move down, hitting a set of stop at which the point cylinder contain saturated liquid line. Saturated liquid. Now it means that, let's suppose this is piston cylinder arrangement. Now heat is removed continuously. So when heat is removed, the piston will be go down. System will be compressed, volume will be decreases, and at a point piston is locked or fixed. At this point piston is locked or fixed, and continuously heat is removed until it reaches to saturated liquid line. It means that from this point continuously at constant pressure heat is removed until it reaches to saturated liquid line. So this is saturated liquid line. So this is point 2. Now the cooling continues until the cylinder contain water at now at 200 degrees centigrade. Now cooling is continue, and in cooling it will go down at constant volume because now piston is fixed. So when piston is fixed and cooling, the system will go down. The line will go down here. This is point 3. If heating, it will go up, and in cooling it will go down. And constant volume line is a straight vertical line on TV diagram. So this is the TV diagram for the problem. Now final temperature T3 is 200 degrees centigrade. Required is number A, find the initial temperature. Number B, the enthalpy change per unit mass. Del H is equal to H2 minus H1 up to the point when per unit mass of the steam by the time the piston first hits the stop. It means that when the system is locked at that point, system is locked at this point. So start is H1 and in is point 2. So find H2. Del H is equal to H2 minus H1. And the finally point C, final pressure and quality. Final pressure P3 and X3 a mixture. So it is mixture in mixture region or in wet region, because at constant volume at heat is removed, then it will be go down straight vertical line, and there is no other region. There is just mixed region of liquid and vapor. So we start solution. First we start initial temperature. So T1 is basically, first we find T1. T1 is equal to saturated temperature plus 5 degree centigrade, because at this point temperature is T1, and here 5 degree rise in superheating, and at this point from this point to this point temperature is constant, which is saturated temperature. So T1 is equal to Ts plus 5 degree rise. So first we find saturated temperature. So from saturated steam table, initially pressure is equal to 3.5 megapascal, which is equal to 3500 kilopascal. So at this point here, saturation temperature is 242.6. This is P1. Saturation temperature is 242.60 degrees centigrade. Now this is not T1, but this is saturation temperature. Now T1 is equal to Ts plus 5 degrees centigrade. So Ts is equal to 242.60 degrees centigrade plus 5 degrees centigrade. So T1 is equal to 247. So initial temperature is a, which is superheating temperature, which is 247.60. Now at point V we find del H, which is equal to H2 minus H1. So first we find H2, H1. H1 is a superheated region. So from saturated steam table, sorry, superheated steam table, at pressure P1 is equal to 3.5 megapascal, and temperature T1 is equal to 247.6 degrees centigrade. Find H1. So if we check the steam table, 247.6 are at 225 values are not available. If we check, this is the superheated steam table, this is the superheated semi superheating, and the pressure is 3.5. It means that pressure is between 3.4 and 3.6. But we check at 225, values are not available here. At 225, values are not available here, and 247 is nearly equal to 250. So we assume that T1 is equal to 250 degrees centigrade. So we assume that T1 is equal to approximately equal to 250. So we will check the values at 3.5 megapascal and 250. So 3.5 is not available. So at T1 is equal to 247.6, approximately equal to 250 degrees centigrade. Pressure in the table in megapascal, pressure is in megapascal, is available in the table is 3.4 megapascal and 3.6, but we have to find pressure find enthalpy at 3.5, and enthalpy in kilojoule per kg in front of 3.4 megapascal, in front of 3.4 megapascal, this is the value of enthalpy, 2835.3, 2835.3, and at 3.5 megapascal and 250 degrees centigrade, this is 2824.0 kilojoule per kg, and here H1 is required. So 3 points, third minus first divided by third value minus second value is equal to third value minus first value divided by third value minus H1. So rearrange this equation and find H1. So H1 will be equal to 2829.65 kilojoule per kg. Now we are finding H2. So H2 is here. This point, at this point enthalpy is a H2, which is equal to HF. So from saturated steam table at pressure P2, pressure is constant. P1 is equal to P2 is equal to 3.5 megapascal because the piston is compressed and heat is continuously removed. So in this condition pressure will be constant. P1 is equal to P2. From from point 1 to point 2 pressure will be constant. So at this point find H2 is equal to HF. H2 is equal to HF and V2. There is no need of V2, but I find V2 for the part C. So H2 is equal to HF and V2 is equal to VF. So at 300 3500, this is the value of HF. 1049.73 1049.73 kilojoule per kg, and V2 is equal to VF at 3005. This is the value of VF. This value 0.001235 0.001235 meter cube per kg. Now we can easily find del H. Now del H is equal to H2 minus H1. So del H is equal to H2 is 1049.73 minus H1 is 2829.65. So change in enthalpy is equal to minus 1779. Enthalpy decreases. It means that enthalpy decreases in cooling. So enthalpy decrease. Negative sign means that enthalpy decreases. Now at point C, point P3 and X3. Now here piston is locked from point 2 to 3. From point 2 to 3 volume is constant. Piston is locked. So here volume will be constant. Now to find P3 and X3. So at this point pressure will be saturation pressure. So and temperature is given to us. So at point 3 pressure will be saturation pressure. So and per X3 find VF and VG, because we will use the equation V3 is equal to VF plus X VG minus VF, and V3 is equal to V2 is equal to V3 is equal to because piston is locked. Now from saturated steam table at temperature T3, which is given to us is 200 degrees centigrade, find pressure P3, which is equal to saturation pressure, and VF and VG. So at pressure P3 at 200 degrees centigrade from this saturated steam table at 200 degrees saturation pressure is 1553.8 kilopascal. 1553.8 kilopascal, and at 200 degrees centigrade VF and VG are VF is equal to, this is VF and this is VG, 0.001156 0.001156 cubic meter per kg, and VG is equal to 0.12736 12736. Now we can easily find PS is already, this is PS, and now we can find x3. So as V3 is equal to Vf plus x Vg minus Vf. So find, this is x3. x3 is equal to V3 minus Vf divided by Vg minus Vf. So x3 is equal to V3, the value of V2 is equal to V3 because piston is locked. Here you can write this point because piston is fixed or stopped. Piston is fixed, so volume is constant. And V3 is equal to, V2 and V3 are equal. This is equal to 0.001235. 0.001235 minus Vf is equal to 0.001156 divided by Vg is equal to 0.12736 minus Vf is 0.001156. Now simplify this and find x3. So x3 is 0.0006259. And this is the end of the problem. And for more videos, please like and subscribe my YouTube channel and share with your friend. Thank you.